In this video, you'll learn about a very important skill necessary for anyone building a circuit. That is the skill of reading resistors to determine their resistance and tolerance. Looking at the diagram I have on the left here, you'll see that resistors, while they all have the same shape and size for the most part, they do look very colorful. Those colored bands aren't just there for decoration, they're there as a code to help you determine their resistance. We'll learn how to decode those colors in this video. The diagram on the right shows you the basics of the resistor color code, showing that the 4 bands correspond to 4 different numbers. The first band, which is red in this resistor, is the first digit of the resistance. The second band, yellow, is the second digit of the resistance. The third band is what we call the multiplier. You'll understand how to use that in a few minutes. And the fourth band is something called the tolerance. I'll explain exactly what the tolerance is as we're decoding the code for this resistor. Important in reading resistors is also a resistor color code, which will be given to you as you read resistors in this class. The resistor color code looks something like this chart that I have here. It corresponds with, or it has 10 different colors, and each color corresponds with a number. There's also a tolerance chart that we'll talk about in a moment. So let's start off by decoding this resistor up here. The first color, which is band 1, is the first digit. In this case, it's the color red, so it corresponds with the digit 2. Second color, being yellow, corresponds with the digit 4. My third color, being my multiplier, means that I write 24 times 10 raised to a certain power. In this case, that power is the number that corresponds to green, or 5. After that, we write the ohm symbol, showing that the resistance of this resistor is 24 times 10 to the 5th ohms. Now that leaves us with mostly everything other than the tolerance. So let's talk about that tolerance for a moment. Every resistor is manufactured in the batches of probably millions at a time, maybe hundreds of thousands at a time. In that manufacturing process, it's very difficult to create thousands, hundreds of thousands, millions of resistors with the exact same resistance. In other words, it's very difficult to create these resistors with exactly 24 times 10 to the 5th ohms. Therefore, when they're creating these resistors, they put something on it called a tolerance. The tolerance helps us calculate the acceptable range of my resistance. We will only deal with a tolerance of either corresponding to red, gold, or silver. But almost every color has a corresponding tolerance, down to 0.01% or all the way up to 20%. The more precise the resistance, in other words, the smaller the tolerance, the more expensive the resistor is. That's because it's a bit more difficult to manufacture ones with such small tolerances. So, taking a look at this resistor here, that fourth band is silver, which corresponds to plus or minus 10%. What that means is that this resistor with these 3 colors on it may actually be 10% more or 10% less than this coded value. Tolerance, again, is just a necessary evil in some ways. One last important thing when you're doing this in the real world is when looking at these resistors like you see here, you may question, well, which is band 1 and which is band 4? Where do I start? Well, the easiest way to say that is that gold can never be one of your other bands. Gold is always band 4. So if you have gold or silver, these 2 colors right here, they're always the tolerance, which means they're always the 4th band. And so the band on the opposite side would be the 1st band. If you don't have gold or silver as your tolerance, typically the bands will be grouped together closer to band 1. You can see that in this diagram here. So even though I do have gold, so I automatically know that this is my 4th band, if this wasn't gold, let's say maybe it was red, I would know that this is the 1st band because they're grouped closest to this end. There's no band over on this end. So take a look at this resistor you see here. What I would like you to do is look at the color chart that I have here and determine its resistance and also determine its acceptable range. In other words, within this tolerance corresponding to the gold band, how low could this resistor possibly be, or how high could its resistance possibly be? We'll talk about what the correct answer is in class the next time we meet.